Hello class, in this video we're going to talk about news vendor problem and how to solve a news vendor problem through simulation in Excel. So if you remember in the news vendor setup, we have one short decision and this single period inventory model, and we want to decide how much we would like to order to satisfy this uncertain demand. The timeline of this problem looks like this. In the beginning of a period, selling season, you have to place the order and then the inventory arrive, then you're going to sell this product, or the unsold product will be serviced at a certain value. The question is, before you know the demand, how much should you order? If you order too many, as you can imagine, you have a high chance to have a lot of leftover at the end of the selling season. If you order too little, then you will lose a lot of sales opportunity in the selling season. So the optimal solution should balance these two costs. So let's see how to solve this problem through simulation. This is the shell I provide you. It has the very basic input here. The unit cost of a product is $20 and the price is $40. You can sell for $40, and the refund unit you return to the publisher can get a refund of $10. That's the salvage value of your leftover inventory. And the demand would follow a normal distribution in this case. It can follow the demand can be generated by any distribution function or even coming from the historical data. But in this case, we're going to study the scenario where demand follow a normal distribution. So the first step is let's first generate a series of integers in this column from 1 to 5,000 because we need to have a number of iteration of 5,000. So let's do that first. And then the next step is generate random demand. So since the demand follow normal distribution, then as we discussed in the previous video talking about how to generate random demand for the normal distribution, basically it's to inverse the normal CDF. The inverse of normal CDF is normal inverse, and the probability is generated through a random variable from 0 to 1, and then we put the mean, which is this, and the standard deviation is this. We lock this to cell because we have to drag this cell. Okay, so we hit enter, then we get a random variable. But there is two problems with this. First, we don't want decimals because demand usually is integer. So we put a round here and choose the number of decimal to be 1. And then we also don't want negative demand, so we want to choose the maximum between this and 0. If it's negative, then we choose a value of 0. Now we get demand. So as you see here, we get sometimes we get a 0 because we generate a negative demand. So we track it to normal. Revenue, cost, and the refund, as well as profit. And the formula, as we already discussed in the class, so I'm not going in detail here. But basically the idea is revenue is how much you sell, right? So it should be your sales price, which is $40. And we lock this cell and multiply by the amount you can sell. The amount you can sell is the minimum of what you have, which is how much you order here. This is order quantity. This is how much you order. Minimum of what you order and what your demand will be. Because if demand is too small, you can't sell all the things you ordered. It's the minimum of these two. We have to log the order quantity here because it doesn't change. The purchase cost is how much you spend to purchase this order quantity. So it's the order quantity multiplied by the purchase cost. You have to log this to cell because we need to copy this into different cells. The amount of refund you have is every unit you refund you get $10, and the total amount of refund is just what you ordered minus what you minus the demand. This is your leftover, but you only have leftover if this is positive. Otherwise, you would have shortage. Your demand is less. Your order is less than your demand, then you have shortage. So you have to put a maximum of this 0. That will give you the total amount of refund. And you also need to log the order quantity here. This is your refund. Your total profit is just your revenue minus your cost plus the refund. This is the profit, and we double click this. Then we get a profit. Oh, we get an error here. What's going on? It seems I made a mistake. Yes, but don't worry. I made a mistake. Oh yes, because I didn't log the unit refund. So let's log this. Then we double click this. Then we get a value. Great. So this is now every time you place a new order, an order quantity that is different from 70, then the profit in different cases will be different. And if we want to evaluate the performance of this order quantity, then we need to do some summary statistics over all the realized profit. And one thing we usually look at is the mean profit, right? What's on average, how much could I earn? So this is just the average of this profit. As you see here, is about $1,166. That's on average how much I could earn. And you can also look at a standard deviation of the profit you earn. So let's use standard deviation as the S represent sample, means because this is a sample. And the standard deviation is quite large. It's about half of the average profit. So there's uncertainty involved in here. Sometimes you earn a lot of good money, sometimes you lose a lot of money because the uncertainty with the demand. The minimum of the profit is this, and the maximum profit is the probability the profit is less than 200. We can use count if. So the first one first parameter is the range. The second parameter is the criteria. So the criteria is less than 200. And since it's probability, we have to divide it by the total number of iteration, which is just to count how many rows we have together. Okay, so we get this chance that we would earn profit less than 200 is 8.5%. And same here with the that we would have negative profit. So we use count if to see how many count we would have negative profit divided by the how many observation we have. So the chance we have negative profit is 5.6%. This two number give you a sense of risk associated with this order quantity. And the next thing we want to do is to evaluate different order quantity. These are the possible order quantity listed here in the data table. And this is so for each order quantity, we would like to evaluate what's the average profit, the standard deviation of profit, etc. So we can compare this order quantity and get the best solution. So this is basically can be done. Basically can be done through data table with multiple column because we have multiple column here. So what we'll do here is just first to construct data table. First, we have to tell them what in the first row. We have to tell them what we want to calculate. So this I put a label here tells you what they want to calculate. First, the column we want to calculate average profit. The second column, we want to calculate standard deviation of profit. Next one, we want to calculate the minimum of the profit. Next one is the maximum of the profit. And then the chance the profit is less than 200, profit is negative. So this is our table. Let me highlight this with color, okay? Because I see somebody is choosing this region as a data table. That's not right, because then this column, first row, is just telling them, the first row doesn't give them information what you want the data table to calculate. So this is your first row, because in this row you tell the data table what you want them to calculate. So let's first highlight this region and then go to data, what if analysis, data table. So what we want to put is the column input cell, because the order quantity is arranged in column, and the things we want to, the cell I want to put is order quantity, because we are going to change the order quantity according to this column. So that's the idea. Press OK, then we get the solution. And you can change the decimal if you don't want to look at those total number of decimal. So this is the profit, and you can do a conditional format to highlight your result. For example, top one item. So this is your solution, because if you look at a average profit, okay, you want to maximize the expected profit, then this is the order quantity you should order, because that will give you the highest profit. As you see here, there's another observation here. Is your order quantity, the standard deviation of of this decision would actually increase. That means it really says every additional unit you order, because the chance that you can sell this product, the risk associated with that product increased, because you are less likely to sell this additional unit. It's just like what we used the example in the class. We have, for example, I want to print out for the students, but we don't have a full class every time. If I only print one copy, then the chance this copy would be taken, it would be very high, because I know almost for certain that people would that at least one student would come. So this is the first unit is the least risky. However, if I go to say 40 copies, the chance that I would the chance that the last copy, the 40th copy would be taken would be really small, really low, because I know the chance that we would have 40 students is really low.